Okay, so modeling with differentiation. Hit pause and copy the lesson objective down. When you're ready, hit play and we'll move on. Right, so modeling with differentiation is going to be the last topic we look at in differentiation. And so dy over dx, or a change in y over a change in x. What we're really looking at though is the rate of change of one quantity with respect to the other. So it's the rate of change of y with respect to x. Now we can change these quantities and replace them with real life quantities and then use that to model a real life situation. So instead of y and x, we can use two completely different quantities that are related to each other. Let's have a look at this example here. So we've got this water tank, and you can see it's going to be filled with water. So the volume of water in this tank is going to change over time. So what we can say is that the volume is a function of time. So V is a function of t. Now if we were to differentiate V with respect to t, then we'd get the rate of change of volume with respect to time, or over time. And this is the sort of thing we're going to be using at the applications of differentiation to real life examples. So I don't think you need to make any notes at this point. We're going to look at an example next. And I think, yeah, you'll have to copy the example down. Right, so let's have a look at this example then. It says, given the volume V of an expanding sphere is related to its radius r, by the formula V equals 4 over 3 pi r cubed, find the rate of change of the volume with respect to radius at the instant when the radius is 5 centimeters. So what we've got to do is, we've got V is equal to 4 over 3 pi r cubed. We've got to differentiate this function with respect to r. So we do dv over dr, which is equal to, with respect to r, so it's going to be 4 over 3 times 3 pi r squared. If we simplify that, we get 4 over, no, not 4 over, 4 pi r squared. I'm going to find the rate of change of the volume with respect to radius when the radius is 5. So when r is equal to 5 centimeters, dv over dr is equal to 4 pi times 5 squared. That's going to be 25 times 4, it's 100 pi. Pi is approximately 3.14, so dv over dr, so d there, is equal to 314 centimeters cubed. So hit pause, copy the example down. Once you've done that, hit play, and we shall move on. Okay, so let's have a look at this example here. It says a large tank, which is shown here, it's got dimensions y by x, is made from a 54 meter squared sheet of metal with no top. So there's no lid on there. Show that the volume of the tank is given by V equals 18x minus 2 over 3x cubed. Okay, so they've given us the area and they've given us the dimensions. So that means that the volume V is equal to x squared y. But they've given us the area, or the surface area. So the surface area is equal to, well, if we look at this front face here, the area of the front face is y times x, so that's xy. But there are 3 of these equivalents, not 4, because unfortunately it has no lid. So that's going to be 3xy. And then you've got 2 sides, which are x squared, so plus 2x squared. Now that surface area is 54. So that implies then that 3xy plus 2x squared is equal to 54. So from this I can find what y is in terms of x. So that means if I say 3xy is equal to 54, subtracting 2x squared, and so y is going to be equal to 54 minus 2x squared over 3x. So now I know what y is. I can sub for y in v. So let's write that down. Sub for y in v. So that means that v is going to be equal to, I think I'll draw a line here and I'll change color of pen. So therefore v is going to be equal to x squared times 54 minus 2x squared over 3x. So I've got an x on as a denominator here. I can cancel that with one of the x's here. So that's going to be equal to x over 3 times 54 minus 2x squared. Applying that, the x over 3 to each term, it's going to be x, so 54x over 3. I tell you what, let me just tidy that up. And I've got blue. So 54x over 3 minus 2x cubed over 3. Well, that's looking good so far. And 3 goes into 54 18 times. So that's 18 x minus 2 over 3 x cubed, which is what we're trying to find. Good. So what we've done is we made use of the information. We made use of the area that they've given us, the surface area, and the volume from the dimensions on the cuboid. Okay, so hit pause, copy that down. That's just part A, and we'll go on to do part B. Okay, so we've managed to show that the volume of a tank is equal to 18x minus 2 over 3x cubed. Now we need to find the maximum volume of the tank. So what would be a good thing to do would be to put this formula in Desmos to have a look at what the curve looks like. And if you have, you should have something like that. And the maximum volume of the tank is going to be here. At that point, it's got a horizontal gradient, so dv over dx is going to be equal to 0. So if we differentiate this equation, set it equal to 0, that's going to give us, we can find x, and then we can sub it back in here to find the maximum volume. Right, so let's do that. So v is equal to 18x. Oops. Go to v equals 18x minus 2 over 3x cubed. It's differentiated with respect to x. It's going to give us 18 minus 2 over 3 times 3. So that's going to give us 2x squared. Now, at maximum, dv over dx is equal to 0. So that means 18 minus 2x squared is equal to 0. So 18 is equal to 2x squared. Dividing both sides by 2, 9 is equal to x squared. So that means x is equal to plus or minus the square root of 9, which is plus or minus 3. In this instance, x is going to be positive. We can't have a negative value for x. So this implies then x is equal to 3. We can now find the maximum volume. Just change to blue. Now V is equal to 18, x minus 2 over 3 x cubed. So when x is equal to 3, V is equal to 18 times 3 minus 2 over 3 times 3 cubed. So 18 times 3 is 54, minus one of the 3 down here cancels one of those, so 2 times 9 is 18. 54 minus 18 gives us, we got 54 minus 18, don't know why I've resorted to the calculator, but 36 centimeters cubed. Okay, so hit pause, copy the example. Once you've done that, I got some questions for you to attempt. That should be meters cubed, not centimeters cubed. Just change that to meters cubed. There we go. Good. So questions for you to do. So a few questions. You just got to take your time with these. There are certain nuances in each question. So enjoy and good luck.